The author group include the Tuan Anh Phạm, phân lợi giác, Hương Lan Chị Vũ. Our presentation include 5 parts. Part 1, introduction. Part 2, materials and methods. Part 3, data use. Part 4, reason and discussion. Part 5, conclusion. Part 1, introduction. It is important to check the foundation before building construction, especially the soft soil. Many studies show that shifting soft soils with cement can increase the stiffness, shear strength, compressive strength, and brittle behavior, and decreasing compressibility and permeability of the material. Especially, it is cheaper than other methods and can use local materials. Unconfined compressive strength (UCS) is an important property and is often used to evaluate the quality.
Your microphone. That's a problem with your.
Can you hear me?
Yes, it's much better now.
Can I repeat? Part 1.
No, next slide, please.
Part 1, introduction. It is important to
next slide, please.
This one is fine.
Okay.
Yeah.
Okay.
There are many methods for calculating UCS, such as unconfined compression test and direct shear test, and the California bearing ratio test. However, these methods often require a large number of samples, which increases cost and time. In recent years, machine learning or artificial intelligence (AI) methods have been researched and applied by many scientists to predict UCS with high efficiency and cost savings. Various machine learning algorithms have been developed for UCS prediction, such as genetic algorithm model, functionation networks, and multivariate adaptive regression supply, multi-layer perception, radiant basic function. However, there are not many studies showing the optimal model architecture for determining the UCS of the soil cement mixture. In this study, we use two methods, namely random forest (RF), random search (RS), to predict the unconfined compressive strength of the cement stabilized soil, in which RS method used to find the best hyperparameters for RF model. Part 2, materials and methods. 2.1, random forest. Random forest RF is one of the most powerful machine learning models based on the decision trees. In this algorithm, a forest of many decision trees is conducted for training and prediction. Each decision tree is an individual with independent predictability that takes input. The final prediction result is the random forest is the mean of member trees. In the random forest model, the important hyperparameters affecting model construction are: 1. Number of trees in the forest. 2. Maximum depth of the tree. 3. Minimum number of samples required a separate tree node. 4. Minimum number of samples per leaf. 2.2. Hyperparameters tuning with random search method. It is difficult to evaluate the machine learning model when it is not optimized. Grid search (GS) and random search (RS) show the sample algorithm and brought out a good performance. The difference between these two methods is that while the RS choose the hyperparameters at random within their range. The GS choose the hyperparameters in the fixed grid. Many studies show that RS method provides better results in many cases. The RS method was chosen to find suitable hyperparameters for the RF model because the RS has a higher chance to find a good solution. 2.3 Performance Evaluation. There are 3 performance indicators have been used to confirm the performance of machine learning model. Square correlation coefficient is closer to 1. The higher the model performance. Other side, root mean square error and mean absolute error value is smaller for better modern cells. Part 3. Data used. In this study, soil samples collected from Hải Dương, Vietnam was mixed with cement to create a mixture of 216 samples, include all parameters that may affect the UCS determination. Table 1. Summary statistics of the dataset of the present study.
Please quickly.
In this, the depth of soil sample as x1, the soil wet density as x2, the curing condition as x3, the curing period as x4, the soil type as x5, the soil moisture content as x6, the kind of cement as x7, weight of cement per 1 curing meter of the mixture as xs, the diameter as x9, the cross-section area as x11, the mass as x13, the density as x14. Part 4, result and discussion.
Dan, you have 2 minutes left. Dan, there are 2 minutes left. Only 2 minutes left.
Okay. 4.1 Hyperparameter tuning of RF model. To prepare the data for the hyperparameter tuning, the original data set was randomly divided into 2 sets, namely training set 80% and testing test 20%. Performance on each RF model based on the 5-fold CV technique to avoid data leak. The model with the highest R2 value is selected as the final model, and its hyperparameters are considered as the best hyperparameter of the RF model. The reason so that the RF model is quite successful in predicting the UCS of the soil cement mixture when the best fitting value on the 5-fold CV reaches 0.826. 4.2 predictability of RF model. It can be seen that the optimal RF model was successful in predicting UCS of the cement stabilized soil. 4.3 Comparing with previous study. The results of the study are equivalent or even higher than the result of the study. However, the research result also suggests that it is necessary to build a machine learning model trained from different data sets to bring the highest generation. 4.4 Future importance analysis. The importance analysis based on the RF model through the increasing the MSE value in our back data was shown in the fig 3. It can be seen that the amount of semen XS was the most important feature. Part 5 conclusion. The main achievement of this study is to develop a random forest model to predict the UCS of the semen soil mixture. The results show that the optimized RF-RS model has an impressive performance in predicting the UCS of semen stabilized. Feature important index analysis by RF model show that among 14 input variables, the amount of semen XS was the most important feature. The result of this study indicates that the RF model optimized by the RS technique can be an effective tool for rapidly predicting the UCS of the semen soil mixture with excellent performance. Thank you for your attention.
Thank you. Does anyone have any question for Lan, please? Okay, so I have 2 questions for you, Lan. The first one is that why did you choose the training to testing ratio is 80-20, but not different ratios such as 70-30 or even 60-40 or something like that?
Okay, as a corresponding also, I will reply this for Lan.
Okay.
So in this study, we use the ratio 80-20, and some literature advice that we can choose the training ratio in range 70-80. In this study, we have more than 200 data, and this is quite large data, and we can use a bigger ratio to make the model get the best rule of the relationship between the input and output.
Okay. Thank you. Can I have another question? Have you ever tried to reduce the input space? Because you have a quite large number of inputs, is 14, I think. And have you ever tried to reduce, because as you can see, X9, X10, X12, 4, 5, 7, I think that these input parameters could be removed from the input space. Sorry.
Okay, I understand what you want to say, but I have no idea about the best range of this data set. I don't know what the range is suitable. Maybe it's quite wide range, but I think with the 10,000 when 1,000 case performed, it will take the good results, good solution.
Okay,